Good morning. Our work with Uniandes studies the interactions between adaptations, and in particular, what happens or what should happen when multiple adaptations are present at the same time. In software system, the system may require to evidence a specialized behavior to particular situations. So in our transport management system example, you may have situations in which the station is full, so you want to close the station and send an additional bus to that particular station. A bus may be full, so you want to send an additional bus to the route served by the full bus. And there may be no more buses to send, in which case you can take out a bus from a route. But the real question here is what happens when multiple of these situations happen at the same time. So for example, what happens if a station is full and a bus is full, or what happens if a bus is full and there are no more buses to send to a route. We identified three different ways in which adaptations interact, which may be independent, meaning that the behavior of the adaptations is completely independent. They may be compatible, meaning that the behavior of the adaptations can be enhanced through interaction, or they be conflicting, in which case interaction between adaptations is likely to break the system. So if you have all the information in this table, then the problem of composing adaptations and the behavior of adaptations is not challenging. However, out of the gate, the interactions between adaptations is not always the same. So two adaptations may interact one way for a particular situation, but may require a different way of interacting for another situation. Of course, if you have all this information from the start, then you can question whether dynamic adaptations are required or not. So we are taking our solution in a case where you don't have this information. You don't know how adaptations should interact. Our solution, called ComInA, is based on reinforcement learning and presents three different components to learn how adaptations interact. The first component, the context agent, is a Q-learning agent that learns the appropriate actions for each individual context. The second component uses W-learning to learn the particular actions, weighting the interactions between all the different agents present in the system. And the third component, called the context composer, gathers all the information learned from the different agents and chooses the best set of actions to execute. That might be a particular action for a particular agent or a composition of the actions for the different agents. The evaluation of is completing the paper and in our presentation, but we want to highlight the fact that ComInA can learn the way in which adaptations interact. So we just define the different adaptations in the system and define no type of interaction between them. And then ComInA learns whether these adaptations are independent or conflicting, for example, and furthermore, it learns when to compose or not the adaptations. So if the adaptations are independent, it can compose them, and if they are conflicting, it just chooses an individual adaptation to execute according to the behavior of the system. So to conclude, we highlight that ComInA is able to learn the way in which adaptations interact, meaning that they are independent, compatible, or conflicting, and based on those interactions, it learns what is the most appropriate behavior for the system.